Hey everyone, welcome, I am Amjith, and today I am gonna share with you AC motors. The basic operating principle of AC motors still involves the interaction between two magnetic fields. In this case, however, both fields are varying in time in consonance with the AC excitation voltage. Therefore, the force between the fields is a function of the angle of the rotor but also the phase of the current passing through the coils. There are two basic types of AC motors, synchronous and induction. The primary motor for application to the control industry is the induction motor. Synchronous motor. In a synchronous motor, the AC voltage is applied to the field coils, called the stator in an AC motor. This means the magnetic field is changing in time in phase with the impressed AC voltage. The armature, called the rotor for AC motors, is either a permanent magnet or a DC electromagnet, and possesses a fixed magnetic field. Synchronous motors can be operated using single-phase AC, but such units are used for only very low power, 0.1 horsepower, and suffer from very low starting torque. When operated from three-phase AC, synchronous motors can be operated at very high power, up to 50,000 horsepower. Induction motors. Induction AC motors are characterized by a rotor which is neither a PM nor a DC excited electromagnet. Instead, current induced in a coil wound on the rotor generates the interacting magnetic field of the rotor. This current is induced from the stator coils. Single-phase induction motors are used for applications of relatively low power, say less than 5 horsepower, less than 3.7 kilowatts. Such motors are typical of those found in household appliances, for example. For higher power we use three-phase AC excitation. Such motors are available up to 10,000 horsepower. Stepping motor. The stepping motor has increased in importance in recent years because of the ease with which it can be interfaced with digital circuits. A stepping motor is a rotating machine that actually completes a full rotation by sequencing through a series of discrete rotational steps. Each step position is an equilibrium position in that, without further excitation, the rotor position will stay at the latest step. Thus, continuous rotation is achieved by the input of a train of pulses, each of which causes an advance of one step. It is not really continuous rotation, but discrete, stepwise rotation. The rotational rate is determined by the number of steps per revolution and the rate at which the pulses are applied. A driver circuit is necessary to convert the pulse train into proper driving signals for the motor. Most common stepper motor does not use a PM, but rather a rotor of magnetic material, not a magnet, with a certain number of teeth. This rotor is driven by a phased arrangement of coils with a different number of poles so that the rotor can never be in perfect alignment with the stator. The direction of rotation of stepper motors can be changed just by changing the order in which different poles are activated and deactivated.